Hi, welcome to my channel. I'm Madam Kong. Today we are going to discuss about tutorial guided module chapter 9 Carbonyl Compound. Are you ready? Okay, let's start. You can open your guided module tutorial and then at the same time you can do the exercise by yourself, at the same time listen to my explanation. Okay, so let's start with question number 1 about give the IUPAC name for each of the following aldehyde and ketone. Okay, so for the naming part, right? Okay, you can do it by yourself. Okay, normally, like the exam, okay, if you get this kind of question, I actually consider it is quite lucky because you are able to answer it. You can, I think, should be no problem for you to name the compound. Okay, first, you have to. I will highlight the functional group first, so I know this is aldehyde. Okay, this one is aldehyde as well. Aldehyde. Okay, this one is ketone. Okay, so now you can differentiate. Okay, both of the compound are considered as carbonyl compound, but carbonyl compound there are two, aldehyde and ketone. So we just have a quick review. For the introduction for carbonyl compound. So the functional group is C double bond O with the general formula CnH2nO. Okay, aldehyde and ketone are isomeric, and then carbonyl compound are polar. In generally, aldehyde is more reactive compared to ketone towards the nucleophilic addition reaction. Okay, so this one is ketone with attached to two alkyl group, and then if aldehyde, right, normally at the end of the structure we see double bond OH and then attached with one alkyl group. Here, okay, so for the naming, right, so the E, okay, aldehyde is named by substituting the letter E of the corresponding alkyl with Al. So for example, aldehyde, okay, have to depends on the parent change. Okay, if one, metana, two, ethana, and so on. Okay, so these are the examples. Okay, actually, it's quite common. If for the carbonyl compound, we use the common name. For example, formaldehyde is metana, ethana is acetaldehyde. Okay, and then the benzene ring. Okay, this is aromatic aldehyde. Okay, so this is benzaldehyde. Okay. So if cyclic, okay, this one called cyclohexene carbaldehyde. Okay, means okay, the C double bond OH attached to the cyclic compound, right? We can call as carbaldehyde. Okay, carbaldehyde. Okay, so for this one also can be carbaldehyde at the position number 2,2-hydroxyl cyclopentane carbaldehyde. Yeah, so this is quite special. Okay, quite special for you. So let's check for the tutorial question. Okay, for ketone actually is O and E. Yeah. Okay. Propanone, acetone, 2-butanone, methyl ketone. Okay, you can put ketone as the parent's name. Okay, when it becomes common name. So let's try here. Guided tutorial. So I try for question A, B, C first. I will start from here. Aldehyde must at the end of the change. 2, 3, 4. So this one is butana. Okay, this one 1, 2, 3, 4. Butana as well, but there is a substituent. Methyl, 2-methyl butana. Okay, 2-methyl butana. Okay, and then how about this one? 1, 2, 3, 4, 5, 6. We must identify the longest change. 6 means hexana. Position number 2, there's a methyl. And then position number 4, there's a chloral. And then position number 5, there is a methyl. Okay, meaning that this one is 2,4 dimethyl. 2,4 dimethyl. And then position number 4, chloral. Okay, but please be careful, Okay, don't be so happy. You have to check for the alphabetical first. This one is from C. This one is for N. Okay, meaning that okay, C started first. So the name supposed to become 4-chloral 2,4-dimethyl hexana. Okay, 4-chloral 2,4-dimethyl hexana. Check for the alphabetical. Okay, now we look for D ketone. Okay, E also ketone. F ketone, G ketone, H ketone, and then this one ketone, okay, this one ketone. With alkene, there are two functional groups, and then this one is aldehyde. J is aldehyde. Here, J is aldehyde, so I try color. This one is aldehyde. Yeah, for the one aldehyde, okay, I highlight with purple color, just saja. Okay. Okay, for the aldehyde, I highlight with purple color. Okay. The functional group still the same, which is carbonyl. Carbonyl, isomeric compound. Carbonyl and ketone are isomeric compound. Okay, let's check for D. This one, okay, because ketone, right? So ketone must at the middle. The C double bond always the middle. So I start from here. C1, C2, C3, C4. Okay, 5. No matter here or here, it's the same. 5. Okay, so position number 3, there is a function substituent 3 bromo 4 ethyl. So the name for the compound D is 3 bromo and then 4 methyl. Okay, the parent chains with 5 carbon pentanone, and then the functional group at position number 2, so 2 pentanone. Here. Okay, now move on to the next question. Okay, I start from here. 1, 2, 3, 4. Okay, position number 3, there is a methyl. So this one 3 methyl, and then 2 butanol. Okay, 1, 2, position number 2. Okay, then how many carbon? 3, 4, 5, 6. So hexanon. So 2 hexanon. Okay, next thing is cyclo. Cyclohexanon. This is easier. Cyclohexanon. Cyclohexanon. Okay, and then this one is aliphatic. Aliphatic ketone. Aliphatic ketone. So position number 2. Okay, position number 2. Okay, this is substituent value. This substituent is value. And then this one 2 ethanol. Ethanol. So okay, for sure already ethanol must add the position number 2. So this is position number 1. Okay, this one method is position number 1. This is number 3. 1, 2, 3. So the one right we can ignore for benzene ring. Okay, for the aromatic compound right, you can ignore the 1, just phenyl ethanol. Phenyl ethanol. Okay, if you check for phenyl ethanol, right, there is a common name called acetophenone. Acetophenone. Phenyl ethanol equal to phenyl ethanol equal to acetophenone. Okay, this one. Okay, 1, because this one is a substituent. Okay, 2, 3. Okay, this is propanol at the position number 2. So 1 phenyl and then 2 propanol. And then there must be number 1. This is 2 cyclohexyl. Cyclohexyl, when it becomes substituent, it becomes hexyl. So 2 cyclohexyl. There are 2 carbon ethanol. Okay. And then the last one, right, K, okay, with the function, there are 2 functional groups. We have to be careful. Okay, if there is carbon-carbon double bond, right, okay, we know it's alkene. So it will involve E and E, some sort like E and E. So we check for the position first. This is position 1, position 2, position 3, position 4, position 5. Always remember, ketone has higher priority. Yeah? Ketone has higher priority. Okay, if you always check for my my ebook, right? Okay, this is my summary notes or ebook. Okay, you check for here. Must always refer if there are more than one functional group, right? Okay, the priority will be given. So carboxylic acid is the highest one, followed by sulfonic acid. Okay, see aldehyde, then cyanoketone. That's why between aldehyde or ketone, right, compare with alkene. Okay, actually the hydrocarbon, the functional group of carbon-carbon double bond or carbon-carbon triple bond is quite lower. So meaning that in this case, the parent names must with ketone. Main name must be ketone. So this one is 2, 2, okay. 5 carbon, right? So 5 carbon suppose is 10. Okay, but quite special. The name is quite special. Okay, for this compound because it involves alkene and ketone. So what is the name of this compound? The name is pen. Okay, pentane, right? Okay, at the position number 3, right? Pen 3 in, and then 2 on. Okay, two pen, three in. Three is referred to the position of carbon-carbon double bond. Okay, here. Okay, here is C3 here, C4. Okay, that's why pen 3 in, and then 2 on. Pen 3 in, 2 on. Okay. Now we move on to question number 2. Okay, draw the structural formula and give the IUPAC name. Okay, the 7 isomeric aldehyde and ketone. So the question gives you the hints already. There are 7 isomeric. Okay, and then combination between aldehyde and ketone with the molecular formula C5H10O. Okay, so now what you can do, right? You just draw the straight change one. You draw the straight line first. Okay, for example, pentana. Okay, you can start with pentanon. Pentana, pentana. Okay, I will start with pentana and then pentanon first. So, okay, I will, no, if I start, I will start with this one, pentana. Okay, with 5 carbon. And then I will start with 2 pentanon and then 3 pentanon. So this right actually is common one. You can think about it. Okay, after that, 1, 2, 3, 4. Then start with butana. Butana with 1 methyl group at the position 2. And then so 2 methyl butana. Or I can start, okay, if I draw the butana, right, for the methyl start at position carbon position 3. So this is C1, this is C2, this is C3. So this one C1, C2. Okay, done for these two. Okay, I also can with 2 methyl groups. So 1, 2, 3. I can draw the propana. Okay, with 2 methyl groups. So dimethyl. Position number 2. So 2, 2 dimethyl propana. Okay. Same for here. After pentanon, right, I can try to draw butanon. Okay, butanon, okay, no matter here or here, right, actually this position is number 2, what? Same, you can try from left to right or right to left, so it's the same. After that, I can draw a methyl group. Okay, the methyl group must not draw at position number 3. So that's why 3 methyl, 2 butanon. Okay, don't simply tell me, madam, can I draw like this? No, because if you draw like this, right, actually this is equal to 2 pentanon. Okay, it's the same, so always remember, jangan fikir, oh tadi stretching macam ni, lepas tu I tukar posisi macam ni. Sebenarnya benda yang sama je. Okay? Boleh ya? Unless you change to here. Okay? The N1 change to the middle one. Okay? Different position. Okay? Hope you all won't mix up. Okay. Done for question number 2. Okay, haven't. Question number B. Aldehyde and ketone with molecular formula C5H8. Okay. Student, you must always remember when the ratio of carbon to hydrogen is 1 to 1, you have to always think about benzene ring. When the ratio of carbon to hydrogen is 1 to 1, you must always think about benzene ring. So in this case, this is benzene ring. Like benzene ring with 6 carbon, so meaning there are another 2 carbon. Okay, outside of the ring. So the answer is like this. Okay, you draw as phenylethanone or phenylethana. Okay, at the end, right? Okay, this one is C1. This one is C1. This one is C2. This is C1, C2. Okay, ethana. So this one is C1, C2. Ethanol. Phenylethanol is position. Actually, this is C1. This is C3. Okay, so this is C1. No. If aldehyde, that one is C1. If aldehyde, okay, aldehyde must be C1. So this is C3. Okay, phenylethanol. No, this is C1, C2, C3. Okay. Okay, or you can draw it as, okay, benzaldehyde. You can draw it as benzaldehyde. So the methyl can be position 2, position 3, or position 4. Here, so these are the isomer for the compound C8H8O. Okay, now draw the structural formula for each of the following compound. I think should be no problem. Propana, no problem. Just a straight change compound 1, 2, 3. Pentana 5 carbon 1, 2, 3, 4, 5, 5 carbon, and then with 3 methyl, 2 ethyl. So this is 2 ethyl, 3 methyl. Okay, for C, pentanol position number 2. 1, 2, 3, 4, 5. Okay, and position number 2. Okay, pentanol, and then at position number 4 there is a methyl group. Alright, yeah, for methyl. So acetone, what is acetone? Acetone is ketone. Okay, propanol. We can call propanol, 2 propanol. Okay, for propanol we don't need to mention the position because only one position. That's why we just call it as propanol. Like just now, right, Daniel? Just now, this one. Okay, the position of the okay, this substituent, right? Okay, sure is number one. Okay, and then ethanol. Okay, ethanol. So one, two. Okay, one, two. So for any, right, you don't need to mention the position because the position only one. Position one. Same for here, because due to the position for this compound, right, just only one. Okay, here, this one. Okay, only one position. So you don't need to mention the two. Just straight away, propanol. Okay, for this one, ethana. Okay, ethana. Alright, is it ethana? E? Yeah, E. Ethana. Oh, ethana. Oh, we call it as acetaldehyde. Acetaldehyde. Acetaldehyde actually is ethana. Okay, next. Where's the parent change? Be careful. The parent change should be like here. So 1, 2, 3, 3, 4, 5, 6, 6. Okay, at position 3. So the functional group at the position 3. And then at the position 4, there is a choral group. So hexanon. Okay, hexanon, 3 hexanon, and then 2 methyl. Yeah, 2 methyl, 4 choral. So 4 choral, 2 methyl hexanon. 4 choral. Okay, this is position number 2, 2 methyl. Okay, 3 hexanon. Okay, the last one, there are 2 C double bond O. Okay, another one is aldehyde, one is ketone. Okay, let's try. This is 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So aldehyde, pentana. Okay, aldehyde, pentana. 1, 2, 3, 4, 5. Pentana. At the position 4, there is a ketone. That's why 4-oxopentana. Okay, 4-oxopentana. This is quite new for you all. Also, okay, and you won't remember this one. This is oxo. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Right. 1, 2, 3, 4, 5. Yeah. So this is pentana. Okay, this is the parent change. Okay, pentana. Okay, position number 4, there is C double bond. All right, we call it as oxo. 4-oxopentana. Okay, now after naming, right, we move on to synthesis. Synthesis. Okay. What I want to remind you, all right, for the question that related with synthesis, you have to think what you have learned in hydrocarbon, benzene, haloalkene, alcohol. Now is carbonyl. Next is carboxylic acid. Okay, and then coming one is maybe you have to relate. Okay, from A until Z. Here. So for this K, right? Okay, the question. Okay, ask. Show how propana can be synthesized from one propanol. So meaning that propanol, 1, 2, 3, okay, and then OH, and then one form propana, C, 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 double bond OH. Actually, it's quite simple. Oxidation with weak oxidizing agent. Yeah, PCC. Okay. The way to write out PCC should be like this. Okay, CH2Cl2. Please do some changes. So this is alcohol, primary alcohol, and then form aldehyde. Okay, if I want to form carboxylic acid, means propanol acid, right? Okay, for example, the question asks, show how propana can be synthesized. Okay, so show how propanol acid can be synthesized from one propanol. Actually, it's the same. Okay, if I want to produce alcohol, right? Okay, sorry, carboxylic acid. Okay, I just use strong oxidizing agent. KMNO4 slash H plus heat. Then I can form the carboxylic acid. Okay. Always remember for primary alcohol, please be careful. You have to check whether you want to form aldehyde or carboxylic acid. Aldehyde have to use the weak oxidizing agent. If carboxylic acid, have to use the strong oxidizing agent. KMNO4 slash H plus here. I hope you all clear about that. Okay, now we move on to B. B is propana, okay, from hexane. Okay, actually this is also a good question. Propana with 3 carbon and then here with 6 carbon. How can 6 carbon suddenly become 3 carbon? So also notice this. Okay. So from 3 hexane, you just break the bond and then become double bond O, double bond O. So you will form aldehyde. You will form 2 aldehyde. Okay. Balancing is not important for organic chemistry. So you can just show propana. But we have organic chemistry really emphasize on method to write the chemical equation. So for example, ozonolysis, we should write out 1 Roman O3, 2 Roman zinc, okay, comma, slash H3O plus acceptable, or zinc, comma, dimethane sulfide, okay, CH3, and then another reagent for 2, right, is zinc, okay, slash CH3, 2 How about question 5? Okay, question 5 also a simple question. Question ha 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 as well, just in the form of sentences. Okay, no problem. Okay, propana. C double bond O H. Okay, first react with sodium borohydride. Okay, actually this is a reducing agent. So for this one, it reduce, right? Okay, how to write it? Okay, plus NaBH4 and then in alcohol, methanol, right? CH3, yeah. Okay, it will reduce. Aldehyde reduce to form alcohol. Okay. You try to complete the hydrogen by yourself, okay, and just show you all the answer. Okay, then the second one is with Grignard reagent. So this Grignard reagent, right, actually is benzene. Okay. So 1 Roman, okay, I'll put it as 1 Roman, benzene, okay, MgBr. Okay, 2 Roman hydrolyzed, H3O plus. So now you know, right? Okay. What is the product? The product form will be C. I know this is become OH, and then here become benzene. Okay, here is the answer. Okay, so later I try to complete the hydrogen with you all. Okay, C, reduce. Okay, reduce as well, reduction as well. So the answer is the same. So if okay, it will become will form the same compound. Okay, this one you have to write down 1 Roman lithium aluminium hydride, okay, and then 2 Roman H3O plus. Okay, we form the same product. So that's why you said actually the answer is the same. Okay, hot acidifier. So this one is oxidation. So again, aldehyde, right? Oxidized will become carboxylic acid. C double bond OH. Okay. So how to write down hot acidifier? Okay, as usual lah. So KMNO4 slash H plus. Okay. Now, okay, I try to complete all the hydrogens for each of the compound. So always remember carbon with 4 bonding. So here's CH2. Here 1, 2 already, so another 2 bonding with hydrogen. Here 1, remain the CH3. Okay, CH3, CH2, CH2OH. Okay, for the answer for this is A and C. Reduce. Both of these, right, are reducing agent. So this one is Grignard reagent, so it will form alcohol. Since this is aldehyde, so it will form secondary alcohol. So try to complete the hydrogen. So this is with 1 hydrogen with 2 hydrogen. This one with 3 hydrogen. Okay, next oxidation. So okay, 2, 1, 2, H2, 1 only, CH3. So these are the answer for D, and then these are answer for B. Okay. Okay, now we move on to chemical test. Okay, as I mentioned before, right, for chemical test, I keep on emphasize must follow the format. First, okay, tell me the test. Okay, what is the test? So in this case, I'm using Tollens test. So you must write down test, which is a Tollens test, Toolens, apostrophe test. Okay, 2, what is the reagent? Okay, 2, what is the reagent? The reagent is this one. Okay, okay, and then this, because this is the answer scheme, right, gives the 3 positive tests with benzaldehyde silver mirror form. Okay, you can ignore it. But now we move on to 3. 3 is about the equation. Okay, this is benzaldehyde react with Tollens reagent, so it will form silver mirror. So silver mirror, this one is the silver mirror form, and then this is the product C double bond O negative. Just copy everything and then O negative. You have to remember the equation, and then you have to remember it. Okay, for this one, this is alcohol. So this is benzene alcohol. Benzene alcohol won't react with silver. So just write out no observer change. And the observation, no silver mirror form. So this is 3, equation 1, 4, observation 1, 5, equation 2, 6, observation 2. Please follow the format. Okay, this is aldehyde with alcohol. We can use Tollens. Hexana with hexanon. Okay, hexana, aldehyde, hexanon, ketone. We also can use Tollens. Okay, this kind ketone at different positions. So in this case, we have to draw the structure first. Okay, B, same thing. Okay, what is the test? Tollens test. Okay, you have to mention this is Tollens test. Tollens, apostrophe test. Okay, and then what is the reagent? Silver ammonia in basic medium. Equation 1, observation 1. Equation 2, observation 2. Okay, Okay, you have to write down no silver mirror form. Okay, you have to write down the observation. One more time, I'll write down one more time for the observation. Okay, no silver mirror form. Just follow like this. Okay, no silver mirror form. Okay, okay, next, both ketone. Now you check for the structure. Ketone. 1, 2, 3, 4. Double bond O. How many? Okay, this is pentanone. Pentanone with 5 carbon. Okay, here, pentanone. 2 pentanone. Position 2. Another one, 1, 2, 3, 4, 5, which is 3 pentanone. If you look it clearly, right, there is a CH3 over here. If there is a CH3 over here, right, okay, meaning that this is methyl carbonyl. Methyl carbonyl. So it will form yellow precipitate. Okay, this is the yellow precipitate. Triiodomethane. Triiodomethane. You can show downwards arrow showing that this is yellow precipitate. Okay, you just copy everything. CH3, CH2, CH2, C double bond O, and then O negative. Plus CHI3. CHI3 is triiodomethane, which is a yellow precipitate. Okay, for this one, right, cannot. So no observable change, and then the observation is no yellow precipitate form. No yellow precipitate form. Okay, precipitate form. Okay, now we move on to question number 7. Okay, draw all possible. Okay, now does not react with phthalate and then with this general formula. Okay, if you still remember what I guide you all for the lab question and alcohol, right? For each of the statement, right, you have to explain. You have to explain for each of the statement. Okay? So for this one, right, the statement, okay, the general formula is CnH2nO. So you can mention this is the general formula for carbonyl compound. Okay, you just explain this one is the general formula for carbonyl compound. You can protect ketone or aldehyde. Okay, second, it does not react with phthalate, meaning that this is ketone. Okay, this compound is ketone because it does not react with phthalate. Okay, but can reduce to an alcohol. Yeah, it can reduce to alcohol from ketone can reduce to secondary alcohol. Okay, by using lithium aluminum hydride. Okay, and then draw all possible structural formulas. So I know 1, 2, 3, 4, 5 ketone. So I can form double bond over here to become 2 pentanone or 1, 2, 3, 4, 5, 3 pentanone. I also can form butanone 1, 2, 3, 4, double bond here, and then there is a methyl here. Okay, so there are 3 answers. This is answer 1, and 1 is answer 2, this is answer 3. Now, madam, try to complete the structure by hydrogen. Always remember 1 carbon with 4 bonding. So mean that here there is another 3 bonding with hydrogen, so CH3. This one 4 already. 1, 2, 3, 4. This one 1, 2 only. This one is CH2, CH2, CH3, CH3, CH2, and then here this one 2, CH2, and CH3. So for this one CH3, here CH3, this one okay with 1 CH, okay, here CH3. Okay, make sure the carbon attached before bonding. Okay, must be 4 bonding, and then complete the structure with hydrogen atom. If you just draw the blue one, the answer is wrong. You have to complete with the green one, the hydrogen atom. Okay, question 8. Show how the following conversion can be carried out. Something like synthesis. Okay, can be 1 step, 2 step, or more than 2. Okay, so propanone to propene. So propanone, 1, 2, 3, propanone, right? Okay, ketone. So you want to form propene. But you have to know, okay, alkene, right, only can be formed from haloalkene or alcohol. So in this case, it's more relevant with alcohol because ketone can be reduced. Ketone can be reduced to become alcohol. So what is the reducing agent? There are 3. You should know. 1 Roman lithium aluminum hydride, 2 H3O plus, or 1 Roman sodium boron hydride, 2 Roman H3O plus. Okay, I think this one changed already. We changed to CH3OH. Okay, follow your directions. It's CH3OH. Another one is hydrogen with catalyst. Can be T and I. Okay, platinum, nickel. Okay. Next, you have done for the first question. Yeah, you have it will form alcohol, and then alcohol react with concentrated H2SO4 heat, it will form alkene. So this is 1 mark, 2 mark, 3 mark, 4 mark. Okay. Okay, A refer to here. You see here, all have to reduce. So now you notice, right? Carbonyl once reduced, it can form many other things. Okay, this one reduced, right? Okay, cyclohexanone becomes cycle 1,2-diol. 1,2-diol, only Bayer test with 1,2-diol. Bayer test with 1,2-diol. Okay, and then want to guide you all. Okay, 1,2-diol, okay, means COH, right? Like this, side by side. Okay, the name for the alcohol side by side, right? Okay, there is another name. Okay, I will always check for vinyl-diol and germ-diol. Okay, vinyl-diol and germ-diol. You have to know what is vinyl-diol, because if the question say about vinyl-diol means side by side. Okay, vinyl-diol. This is vinyl-diol. VINYL, vinyl-diol. Okay, if the nucleophilic substitution, okay, like this. This one we call it as germinal diol or germ diol. Okay, the OH group attached to the same carbon. So this one is, okay, same carbon, we call it germ diol. And then this one side by side, okay, involve two carbon, we call it vinyl diol. Okay, now, okay, so Bayer, right? Okay, Bayer means must from alkene. So if alcohol from alkene, right? Okay, must from alcohol. How? Reduce the ketone. Reduce the ketone from secondary alcohol by using strong sulfuric acid. Heat, and then it will form alkene. Alkene undergo electrophilic addition or Bayer test. Okay, Carbonyl common hydroxide. Bayer with hydroxide and then undergo electrophilic addition. Okay, this one pentanone. Okay, chloropentane haloalkene. Yeah, also can undergo electrophilic addition by adding HX. Okay, chloro HCl. Okay, since HCl, right, we can accept HCl, SOCl2, PCl3, PCl5. Also, no problem. Okay, up to you. So it will come out here. So first, ketone undergo reduction from alcohol by using the reducing agent. Okay, from alcohol. And then alcohol, right, okay, undergo nucleophilic substitution. Okay, HCl. Okay, undergo nucleophilic substitution HCl and then from haloalkene. Okay, I think should be no problem. Okay, question 9. Okay, soalan yang mana paling suka sekali lah soalan 9. Soalan 9 ni lah soalan senang. Okay, soalan 10 pun soalan senang. 9, 10 senang. 11 boleh lagi lah. Okay, and then 12. 12 memang tak suka. Bukan you tak suka je. Madam pun agak tak suka. Tapi sebenarnya dia seronok. Okay, mengapa? Tengok soalan dia. CH ratio 1 to 1 mesti benzin lah. Macam tu lah. Kalau buat banyak latihan akan tengok soalan pun tahu dan jawapan apa dia. Okay, jom kita tengok. Soalan 9 lah. Okay, this is aldehyde, this one is alcohol. Reducing agent, this is reducing agent. Jadi madam terus tahu dah. Semua saling balik je. Sini semua saling balik. Okay, that last tu akan jadi COH. CH2OH. Okay, ini jawapannya. Okay, semua saling balik je. Aldehyde tu akan jadi no. Aldehyde. So dia become alcohol lah. Saling balik semua. Aldehyde tu akan jadi alkohol, betul tak? Betul, betul dah kata saling balik je. Okay, yang aldehyde tu akan jadi alkohol. Itu je lah. Okay. Yang ini pula. HCN, nucleophilic substitution. Nucleophilic substitution asal dia bukan nucleophilic substitution. Kerana kat sini dia akan jadi alkohol. Ini akan jadi CN, addition. So this is addition. Addition. Jadi jawapan untuk B ialah, okay, you just salin je buat benzene ring, salin benzene ring. Asalnya kat sini ada CH3. Okay, maksudnya ini ialah ketone. Okay, ketone. Undergo nucleophilic addition. Okay, undergo nucleophilic addition. Tengok. Ya, C double bond O. Ya, salin je. Okay, CH3, C double bond O, CH3. Nucleophilic addition. What is the type of reaction? This is nucleophilic addition. Single bond jadi double bond jadi single bond addition. Yang ini ada silver mirror. Jadi tolerant lah. Okay, O negatif sahaja. Maksudnya dia mesti dalam rautan OH negatif. Okay, silver mirror. How to write out the silver mirror reagent? Ini agak susah. NH3 kurungan 2. Nak tengok. NH3 kurungan 2. OH2 negatif. Jadi mesti sesuatu yang positif kat sini. Jadi silver kan, silver jadi mesti ada Ag lah. Jadi Ag, lepas tu NH3 ammonia ni. Okay, ada dua ammonia with positive charge and then slash hydroxide. Okay, slash hydroxide. Okay, slash hydroxide. Here, kalau sini O negatif Na plus, maksudnya sini ada NaOH ya. Okay, next. Asalnya sini ialah alkohol. Jadi aldehyde, oxidation lah. Ini ialah oxidation. Ini ialah oxidation. Okay, kalau you dah tengok video briefing manager pasal carbonyl kan, manager ada beritahu. Okay, it started from alcohol. Okay, it can be oxidized, become ketone or aldehyde. Okay, sudah berbuat olah carbonyl. And then it can continue oxidize, become carboxylic acid for the aldehyde compound lah. Okay, or it can straight away from alcohol, primary alcohol, right? From the primary alcohol, straight away become carboxylic acid by using the strong oxidizing agent. So the reverse one is reducing. Okay, reducing. There are three reducing agents that you should know. Lithium aluminum hydride acidified, or sodium boron hydride with methanol, or hydrogen with catalyst. This is a reducing agent. Okay, next. This is Butyl-Kraft acylation. Butyl-Kraft acylation. So this is from the reagent. Here is from the reagent, so which is C double bond OCH2. So mean that E is a benzene. Undergo Butyl-Kraft acylation. Okay, E is a benzene. So what type of reaction? Electrophilic aromatic substitution. This one oxidizing agent. So become C double bond O OH. From butana become butanoic acid. This one, do you still remember? This is what? This is condensation. Condensation. This one is condensation. Okay, so ketone can react with 2,4-dinitrophenylhydrazine. So this is ready test. Okay, so it's eliminate H2O. So I will take the O from the ketone and then H from the hydrazine. So just join it. Okay, just join it. Double bond, C double bond, and H. Okay, everything just copy and paste. Okay, just follow. Yeah, this one is the answer. Simple, right? As long as you remember the concept, no problem. Okay, so this one, clean up reagent, so I know already. So I just copy here for the carbonyl compound. I just copy CH3, CH3, and then the double bond O will become OH. And then here you attach with the C here. So CH2, CH3. Okay, settle. So this is the answer. When clean up reagent, right? Okay, react with ketone, it will form tertiary alcohol. So this is tertiary alcohol. Okay, addition as well. This is nucleophilic addition because from double bond becomes single bond. So this is nucleophilic addition. This one is condensation. Condensation reaction. Condensation. Okay, and then this one is oxidation. Okay, this one is electrophilic aromatic substitution. Okay, when you do this kind of question, right, you must always try to identify the type of reaction. Okay, now for question number 10. Complete the following reaction scheme and write the structure formula for A to C and then the reagent as well. Be careful, there are two questions. One is about the compound, another one is about the reagent 1, 2, 3. So let's try to do it together. Alcohol, yeah, concentrated H2SO4, I know it from alkene. Okay, and then this one, alcohol, and then react, and then form Br substitution. So I choose HBr. Okay. And then oxidation, this one oxidation. So what is the reagent for this oxidizing agent? Okay, because be careful, this is alcohol, primary alcohol, and then it form form aldehyde. Okay, propanol form propana. So this is weak oxidizing agent. So meaning that the reagent is PCC/CH2Cl2. Okay, reducing. Okay, reduce. Okay, reduce, right? So A is alcohol. And then alcohol. Okay, and then undergo substitution. So 3 is HCl. Okay, any can be PCl3, PCl5, SOCl2 also no problem. You check the answer? Yeah, right? PCl3, PCl5, SOCl2, HCl also can. And then for number 1, HBr, okay, can be PBr3, PBr5 as well. Okay, we check for number 2, where is the oxidizing agent? Okay, 2, where is 2? Yeah, here. Okay, why? So you have to get the B first. Okay, you have to get the B first. Okay, I try to get the B. 1, 2, 3, and then here become OH, and then it will connect. It will be connected here. So which is CH2, CH3, and then here is the hydrogen. Yeah. So this one is the compound. Okay, this is the alcohol. Suddenly alcohol becomes ketone. So meaning that this is oxidizing agent. So oxidizing agent KMnO4/H plus. Okay, for information, this one also oxidizing agent. This and this actually is the same. Okay, both of these reagents actually is the same thing. Just this one is the complete one. One Roman sodium potassium permanganate right in basic medium and then followed by acidify. Okay, heat. Okay, we make it simple. So become KMnO4/H plus heat. So you just follow the simple version. Okay, so done for compound 1, compound 2, and compound 3. We have done for E, I, A, B. Okay, now remain C. C. This is aldehyde. So, and then oxidize. Propana, then it become propanoic acid. Strong oxidizing agent. So 1, 2, 3, double bond O, OH. Now, propanoic acid react with methanol. So reaction between carboxylic acid and alcohol, meaning this is esterification. Esterification. Mass with concentrated H2SO4 and heat. So now, okay, as I told you all before, it will eliminate the OH from the carboxylic acid and then eliminate the H from the alcohol. So then it will become, okay, I just copy the carboxylic acid first, C from the part of carboxylic acid, and then connect here the O from the alcohol, and CH3. Okay, try to complete, okay, oxygen with 2 double bonds, so 1, 2, CH2, here's CH3. Okay, now I try to complete all the structure, CH3, CH2, C, okay, CH2, 1, 2, 3, 4, OH. So this one, 1, 2, right, so CH2, here 1, 2, 3, so CH, and then here CH3. Okay, for this case, CH3, CH2, okay, full, okay. Done. Oh no, wait, this one. CH3, CH2, okay, C double bond OH. Okay, I hope you all can understand. If you know, if you remember all the reaction, right, the preparation of the certain compound or the chemical reaction with certain compound, you can finish this question within 5 to 10 minutes. No problem. Just be careful when you draw the structure. Make sure one carbon with 4 bonding. Okay, there is no extra or lack of HR, no extra hydrogen atom or lack of hydrogen atom. Okay, make sure the position of the substituent is correct. Okay, yeah, time for question number 10. Now we move on with question 11. Yeah, same thing. Okay, so draw the structure A, B, C, D, E. What is the rules to predict the structure of D? Actually, until now, right, you just learned for 2 rules. One is Zajac rules for the dehydration of alcohol. Another one is Markovnikov rules for the electrophilic addition. Okay, one of the chemical tests distinguish D from E by using bromine in inert solvent dichloromethane. Okay, for sure this is bromine, right? Normally it's used to differentiate between alkene and alkane. Take the observation and write the chemical equation because the question asks about distinguish between D from E. So meaning that when you answer this question, please follow the 6 steps. What is the name of the test? What is the reagent? Equation 1, observation 1, equation 2, observation 2. I hope you're quite clear about the chemical test, how to answer the way to answer the chemical test. Okay, the last one, state the type of reaction involved information. Okay, so I will go through the question first because I want to know what question you will use. Okay, rules and then chemical test, and then this one is type of reaction. Then only return back to the question. Okay, this is ketone. So ketone. Okay, I know this is nucleophilic addition. Nucleophilic addition. So A will become CH3, CH3, and then here become OH, and here CN. Okay. Something new for you all for the part B. Okay. This will learn next for next chapter, carboxylic acid. Okay, preparation of carboxylic acid by nitro compound. So meaning that this one, right? Okay, you just copy everything. CH3, COH. Okay, and then here CH3, and then the CN, right? It will become COOH. Here, be careful. This is double bond O become OH and CN. I just circle or highlight the part that have changes. Okay. This is hydrolysis. Okay, this one reducing. Ketone reduce become alcohol. So CH3, C here become OH, and then here CH3 still the same. Okay, 1, 2, 3 bonding only means there is no hydrogen here. Okay, this one green light reagent. As I told you all right, every time when you solve the problem related with green light reagent for the ketone part, right, you just copy CH3, C, CH3, and then the double bond all become OH. Okay, and then here, right, you attach with here. Okay, the C that attach with the magnesium bromide, now the C will attach with the C that attach with the double bond over, so it becomes CH2, CH3. Okay, so this is tertiary alcohol, and then it will be concentrated H2SO4 heat, right? Meaning that this is dehydration of alcohol. We form the carbon-carbon double bond. Okay, since the question asks about major product, you have to know it can form double bond with here, okay, or here. So these two is the same. These two are the same, or you can form the double bond over here. Okay, I know the purple one is major product already because according to Say-Jeff rules. So mean that what is the rules used to predict the Say-Jeff rules? Please check for the spelling. S-Y, S-A-Y, say, S-Y, S-A-Y-T, say, Z-E-F-S, apostrophe, Say-Jeff rules. Okay, so what is the answer for D? I know already. The D, right, is CH3, C, CH3. This is a double bond here. C, okay, H, CH. Don't be CH2 because here C, one bonding, two bonding, one with hydrogen, and another one is CH3. So this is the answer for D, major product. Okay, this is the answer for D, major product. Just the position. Okay, and then E done already. So get it here? Okay. Why this one is the major product? Because when you highlight the C double bond C, right, there are three alkyl groups. If you form the double bond here, right, if you form the double bond here, there is only two alkyl groups. So that's why the major product is this one. Okay. Observation. Okay. Yeah. This question I answer for the three equation one, observation one, equation two, observation two. Okay. But it didn't mention for the test, right? So you better follow us. So remember how to write down the bromine test. You cannot write down bromine test. Bromine test we write as okay. Kalau test tu boleh tulis sebagai test, memang akan tulis test. For example, Bayer test. Kalau itu bukan test, kita tulis reaction. So reaction with bromine in CH2Cl2. Reaction with bromine in CH2Cl2. So you just tulis macam ni lah. Okay, yeah. Okay, you just draw like this. Okay, what is the test? So test dot. Okay, reaction of bromine solution in dichloromethane, or just write down CH2Cl2 like this. So what is the reagent? So reagent, right, you just write down Br2, okay, slash CH2Cl2. Okay. So this is the reagent. Br2 comma. Okay, just follow the comma. For me, it's the same, no problem. Okay. Okay, if you're able to write down bromine, CH2Cl2, right, actually it's very good already. Okay, I know you all can do it. Okay, no problem. So bromine, you check, okay. The way to write down the reagent Br2, okay, it's based on here, right, as I told you before, there is Br2. Br2. If compare between alkane and alkene, right, so must at that condition, but this one no need because for alkane, alkana, no observable change. Okay, no reaction. Okay. What is the reaction of the E? Reducing reduction? Yeah, I already here already reduction. Okay, question 12. Question 12. Compound W and X have the molecular formula CHA. Okay, so you have to explain this statement. Okay, what is this statement stand for? Okay, this one you have to write down. Yeah, the answer scheme not stated, but you have to write down. You have to write down. Have to write down. Semua orang kena tahu setiap ayat untuk soalan yang di you kena terangkan. So kita tak tahu markah tu bagi macam mana. Jadi kita buat yang terbaik. Cuba buat yang terbaik. So the ratio of C to H is 1 to 1, showing that benzene ring is present. Showing that benzene ring, okay, is present or consists of benzene ring. Ikut ayat anda lah. Bahasa dia pun tak okey kan, tapi ikut boleh faham kan? Show benzene ring is present. Okay, now second statement. W react with hot acid by hot pellet produce split acidic. Okay, so from here I know W is aldehyde. W is an aldehyde compound, while it gives the positive test towards spelling reagent, which is split acidic. Madam sebut je lah, you tulis sendiri ya. Okay, Madam ulang. W is aldehyde compound because it gives the positive result towards spelling reaction, which is split acidic. Boleh? Okay. Next sentences. X gives negative result towards spelling test, but it reacts with lithium aluminium hydride followed by hydrolysis from alcohol. Okay, kerana X bagi negative result towards spelling, so meaning that this compound is ketone. Why? Okay, because it gives the negative result towards spelling and it will produce, means it's undergo reduction. Okay, lithium aluminium hydride, okay, followed by hydrolysis is one of the reducing agents. So it will reduce to form alcohol 1. So meaning that X is ketone compound. Okay, now next. Both X and Y react with iodine sodium hydroxide to yield yellow precipitate. So since one is ketone and the one is aldehyde, right? And then give the positive result towards iodine. Okay, you have to mention, right? Both X and Y contain methyl carbonyl group. Okay, so now determine the structure for W, X, and Y. Okay, after that, give the product of the reaction. Means write down the equation. Give the product of the reaction, meaning that it's write down the equation. Okay, between W and lithium aluminum hydride. Okay, these are two equations. And then number 2, acidified potassium dichromate solution respectively. Okay, actually, right, while you explain for this part, right? Okay, I will show the equation as well. I will show the equation as well because when you write down the explanation, when you show the equation, right, actually you are trying to deduce the structure by giving a proper explanation. So let's check one by one. Okay, yeah, red precipitate. Okay, showing that. Okay, okay, look at here. When you write down red precipitate, meaning that this is aldehyde. Yeah. Okay, and then it forms primary alcohol. Okay, when reduced become primary alcohol, this is carbonyl. Carbonyl is aldehyde. Okay, for X, right, no change for the Fehling reaction, meaning that this is not aldehyde. Okay, this is not aldehyde, might be called ketone. And then it forms alcohol Y. So compound, right, this compound X, right, is carbonyl. It does not react with Fehling solution. Okay, therefore it's ketone. Okay. And then positive test, right, contain methyl carbonyl. Carbonyl, okay, carbonyl, methyl carbonyl. If alcohol, methyl carbonyl. Okay, and then for this one alcohol, right, so methyl alcohol or methyl carbonyl. Kena ingat, kalau ada methyl group bagi carbonyl, bagi methyl carbonyl. Kalau ada methyl group bagi alcohol, methyl alcohol ataupun methyl carbonyl. Okay, next. So this is aldehyde. Okay, and then this one is ketone. Okay, and then this one is secondary alcohol because from ketone, because it formed from ketone. So from ketone, right, ketone reduced will become secondary alcohol. Okay, because ketone reduced will become secondary alcohol. So aldehyde oxidized become carboxylic acid. Okay, because using the strong oxidizing agent. And then aldehyde reduced, right, will become alcohol. Yeah, that's all for this discussion for the guided module tutorial. So you can try the 6 objective question by yourself. Try it by yourself, even though Madam did. Okay, I try to explain the things. Okay, what time is now? Okay, almost 1 hour. There are another 5 minutes and become 1 hour, right? So be fast. Within 5 minutes, we discuss the 5 objective question. Okay, so this structure. The name of this structure is R-corin. Okay, kalau you bagi nama ni sebelum Madam lukis, Madam pun tak tahu. Sebenarnya Madam pun tak tahu. Okay, this is with ketone, ketone with aldehyde and carbon-carbon double bond. Okay, which of the following is not true regard? This one. Okay, does not inhibit stereoisomer. Stereoisomer kena tahu stereoisomer ada dua, cis trans ataupun enantiomer. Masih ingat cis trans kena ada carbon-carbon double bond, ada, tapi ini H2 tak boleh lah. Kemudian C kena ada sp3 carbon, tak ada. Jadi ya, dia tak wujud. Oh, the bond angle in the molecule approximately 90. 90 means linear. Linear. Tak, sebenarnya ini tak. Ini trigonal planar. Bahagian ni lah trigonal planar. Yang sini, yes, kat sini linear. Tapi kat sini lah trigonal planar. Jadi bukan O. So, salah lah. Tak apa, jawab dulu. Electrophilic and nucleophilic addition, ya. Kat sini electrophilic addition. Kat sini nucleophilic addition. Betul. It decarries aqueous bromine and acidified potassium dichromate solution. Okay, kerana ada carbon-carbon double bond, yes, can. Okay, kerana dia aldehyde, yes, can. So, jawapan dia B. Okay, satu ialah sepatutnya 120 dan satu ialah 90. Yes, answer correct. Okay, now, check for here. Choose the suitable greener reagent that can use to prepare 2-methyl 3-pentanone from propanol. Okay, kena lukis lah. Pentanol. 1, 2, 3, 4, 5 pentanol. Position number 3. And then here there is a methyl group. Okay, dari propana. 1, 2, 3. Okay, propana. So, kena tahu lah sini ada 3 carbon lagi. Jumlah ini 6 carbon. Jadi, greener reagent anda mesti ini 3 carbon campur 3 carbon baru jadi 6 carbon. Ini first criteria. Jadi, pastikan compound ini semua 3 carbon. Ini 2 carbon terus out lah. Ni 4 carbon terus out lah. Boleh faham? Kerana jumlah dia 6 carbon. Carbon ni tak ada 3. Jadi kena ada 3. So antara 2 ini yang mana akan peduli. So nampak tak sini ada methyl. Jadi tak boleh strict change. So rasanya tu jawapan dia C. Jom tengok betul tak? Idealnya macam tu je. Ya betul. Okay. Wah Madam hebat. Kerana Madam nak buat banyak latihan dah. Jadi you all pun kena buat latihan lah. Jadi buat latihan akan semakin macam Madam. Sebab Madam tak mahir pun. Okay. Kerana Madam nampak sini. Okay, I tak alkohol dia sini. Okay, Madam tunjuk kerana I dah bahagian ni dari sini. So, jadi bahagian ini kan, I mesti ada satu methyl. Dia mesti L shape, dia tak boleh straight change. Dia attach kat C2. Ini attach kat C1. Jadi tak boleh lah. Dia mesti kat attach kat tengah-tengah. Kemudian atas ada CH3, maka dia jawapan inilah. Okay ya. Butana can be distinguished from butanol by using the following reagent except shift boleh, tolon boleh. Okay. Iodoform boleh ke tak? Kena butanol. Iodoform boleh ke? Bromine boleh ke? Okay, shift tolerant for sure can. Okay, butanol we try to draw it out. Butanol. Yeah, can. Okay, because here there is a methyl group here. CH3 here. CH3 here. Sebenarnya kalau logik kita pun tahu bromine kita tak belajar kat carbonyl. So bromine biasanya tak boleh. Yang itu kan. So the answer is Tauki. Here, kita tak belajar bromine water pun untuk carbonyl. So Tauki, yeah, correct. Okay, which of the following would attack the carbon? Okay, nucleophile lah. Kerana Asyik belajar nucleophilic addition. Nucleophilic addition, yeah. Okay, so 2-hexanon and hexana can be distinguished by, this is ketone, this is aldehyde. Brady tak boleh kerana Brady dua-dua pun akan bagi dia balas. Tolon, yes. Hexana and hexanon, yes, can. 2-hexanon, there is a methyl group for 2-hexanon. So answer 2 and 3, C. Yeah. Okay, the last question. Compound Y give an orange precipitate. So this is carbonyl and then positive iodoform. Then this carbonyl right must be methyl group. Ethana 1, 2 double bond OH. Yeah. Okay, yeah, there's a CH3. Propanon 1, 2, 3 double bond O. Yeah, there's a CH3 can. And then 2 propanon 1, 2, 3 OH. Yeah. Here, yes. Okay, this one can give the iodoform, but cannot for the Brady test. So the answer is 1 and 2. Okay. So, okay. That's all for this video. Hope you all can learn something for this 1 hour tutorial guided module chapter 9 carbonyl. Okey, harap anda belajar sesuatu melalui perbincangan tutorial guided modul melalui video ni ya. Okey, jangan lupa subscribe channel Madam and like video ni. Okay, bye bye. See you all on next video. Bye.